Welcome. In this video, I'm going to go over the solutions to the problem set for 3.1. This isn't a real long problem set, so it shouldn't be a real long video. Number 1 in the exercises says use the IB periodic table to identify the position of the following elements. And so the period is whatever row it happens to be in, whereas the group is the vertical column that it lies in. So helium is technically in period 1, it's in row 1, and grab my pen here. It's in row 1, and technically it's in group 18, although occasionally it's put with group 2 because it has just the 2 electrons, but most periodic tables put it over in group 18 with the noble gases. Chlorine, if I look, is in period 3 and group 17. Again, most countries other than the United States uses the 1 through 18 numbering system. They don't bother with the A and B's, although if you use A and B designations, that would be acceptable. Barium's down in period 6 or row 6, and it's in family 2. And francium is in period 7 and family 1. Question number 2 says, phosphorus in period 3 and group 15 of the periodic table. Distinguish between the terms period and group. Period is the horizontal rows, and it corresponds to the energy level being filled. Whereas the group is the vertical columns, and it corresponds to the number of valence electrons. And then part B asked you to state the electron configuration of phosphorus and relate it to its position in the periodic table. And there's really 3 different ways you can do this. You could write the full configuration for phosphorus, seeing that it has 15. You'd see that the first level is full, the second level is full, the third level, the S is filled up, and the P has 3 in it. Otherwise, you could use the noble gas configuration of neon and then 3s2, 3p3. Or you can use the super shorthand that IB uses where you add up the whole floor. So floor 1 is 2, floor 2 has a total of 8, and floor 3 has a total of 5, and you just write 2, 8, 5. And the correlation with its group number is that you notice that there are 5 valence electrons which corresponds with its group number. Now technically its group number is 15, but you ignore the 1s when you get up to, so we're looking just at what we call the representative elements, so the S block and the P block, and their valence electrons are equal to the last digit of their group number technically. Number 3 then, how many valence outer shell electrons are present in the atoms of the element with atomic number 51? And when I find 51, I see that it's SB or antimony, and it's in family 15 as well. So it also has 5, just like phosphorus. Question number 4 asks, which of the following elements is a metalloid? So because I use the singular, I assume only one of these is a metalloid. But the real thing is to go ahead and look at the periodic table, and you're looking for that zigzag line that separates metals and nonmetals, and any element that has a side touching, a full side in common with that zigzag line is considered a metalloid. So calcium and magnesium, way back over in families 2, are not. Manganese is a transition metal, so it's just C, germanium, that would be considered a metalloid. Number 5, which of the following materials is the best conductor of electricity in the solid state? So with number 5, I'd assume it's a metal, but when I look at these, silicon is not a metal. Graphite, it's not even an element, although it is, it's carbon. Phosphorus is a nonmetal, and antimony is along the metalloid border there. So what they're getting at here is that graphite is a particular configuration of carbon that gives it good conductivity. And that's one you just have to read in your reading, not one I'd lose sleep about. If you happen to know it and it comes up on the test, great. Number 6, which of the following properties is used to arrange the metals in the modern periodic table? Is it the mass, the number of valence electrons, the atomic number, or the effective nuclear charge? Well, originally it was the mass, but then they found out that that doesn't always work, so it's actually the atomic number or number of protons that's used to arrange them.